Hello class, welcome to this video on the density practice. So we're going to cover problems related to density, which is you can consider it to be 11.5, although it's not part of the book, but we'll consider it to be 11.5 practice for chapter 11. All right, let's go ahead and get started. So for the first one, we have first couple of questions. We have some data on population density of cities. So we have city of London, Paris, Madrid, and Sydney. So we want to figure out the population density of London. So the population density, remember the density is always the characteristic you want to measure over the some kind of length, area, or volume. So if I want to calculate population density, then it's going to be the population over the area. All right, in this case. So in this case, we're looking for density of London. So we got the population of London over the area in miles squared. So this is people on the top, and on the bottom is 607. So if we were to calculate this, remember that the units are going to be in people per mile squared, people on the top, right? So we have 8674. Let's put this on the calculator here. You get approximately 14,290 people per square mile. All right, or persons per square mile, depending on how you want to say it. All right, so Paris, France, we got the density of Paris is 2,224,000 people over 40.7 square miles. Get 54,644-ish. We're just rounding this to the nearest whole here. We got people per square mile. All right, so now for the next couple exercises, it says find the indicated measure. So it says about 210,000 people live in a region with a 12-mile radius. Find the population density and people per square mile. Since it says it's a 12-mile radius, we're looking at a circle with radius 12. So therefore, remember that the area of a circle is pi r squared. So it's going to be pi times 12 squared. All right, so we got the density is 210,000 people divided by pi, the area, times 12 miles squared. We'll do all of this at the same time on the calculator. Remember, when you do this on the calculator, make sure you put like a bracket or parentheses on the denominator just to be on the safe side. And you get about 464 people per mile squared. All right, so for number 4, we got about 650,000 people live in a region with a 6-mile radius. Find the population density. This is the same deal. So we got D is 650,000 people over our area, which is pi times 6 miles squared. And I'll leave it to you guys to calculate that decimal there. For number 5, a region with a 4-mile radius has a population density of about 6,366 people per square mile. Find the number of people who live in the region. So this time they give you a density. And so remember, so we're going to plug this into here. All right, so the density is that's D. This is the radius, right? So we're looking for the population. All right, so 6,366 people per square mile is equal to, the density is equal to the population, which we'll call X, over the area, which is pi times 4 squared. Remember, the area of the circle is pi r squared. So there you go. And so this is going to be 16 pi. Okay, so let's go ahead and rewrite this. We got 6,366 is equal to X over 16 pi. And if I want to get rid of the 16 pi on the bottom, remember it's being divided, so I got to multiply it. So I'm going to multiply both sides by 16 pi to cancel. All right, so there you go. There's my population. My population is 6,366 times 16 pi, and I'll leave it to you guys to calculate that, okay, on the calculator, and then round it to the nearest whole. About 79,000 people live in a circular region with a population density of about 513 people per square mile. Find the radius of the region. Okay, so the density is 513. That's our D. 513 is equal to the population over my area, right? My area, we don't know the radius, so that's going to be r. So it's going to be pi times r squared. So we got to solve for r. So what we're going to do is we're going to swap these two. We're going to swap this and that, okay? And that's called, that's a Lynch swap. That's what we call it, the Lynch swap. And so we swap those, and we get r squared equals 79,000 over 513 pi. There you go. We swapped them, right? And so now we can take the square root to get rid of the squared here. And that'll give us r. So r is the square root of 79,000 over 513 pi. Make sure you put this in parentheses. I'll leave it to you guys to calculate that radius. All right, determine the mass of an ethyl alcohol that exactly fills 300 milliliter container. So that's our volume right here. If the density of the ethyl alcohol is 0.789. So they give us a density D. Now this is a different type of density. This is not a population density anymore. This is a mass volume density. Okay, so this density is, the formula for that is mass over volume. Okay, so now we know that the volume is 300. We know the density, so we're trying to find the mass. So let's plug in for D. D is 0.789. So 0.789 is equal to mass, which we don't know, over volume, which is 300 milliliters. Okay, so now we can multiply both sides by 300 to cancel. And I'll leave it to you guys to calculate that mass. Do 300 times 0.789. The units for that are going to be in grams. So the answer is going to be in grams. The units for number 6 is going to be in miles because we're talking about people per square mile. All right, so for number 8, a certain block of lead has dimensions of a 5.2 inch by 4.5 inch by 6.0 inch rectangular prism and weighs 1,587 grams. Determine the density of the certain block of lead. Okay, so this is going to help us calculate our volume, right? So our volume of a rectangular prism is just multiplying length times width times height, right? So we're going to multiply those. So it's 5.2 times 4.5 times 6.0. And that'll give us our volume in inches cubed, right? This is in inches here, so it's going to be inches cubed when we multiply them. So 5.2 times 4.5 times 6 is 140.4. It's going to be inches cubed. Now the mass is in grams, 1,587 grams. So the density is mass over volume. So the mass is 1,587 grams divided by 140.4 inches cubed. So the units for the density are going to be in grams per inches cubed, right? It's going to be grams per inches cubed, like that. I'm going to leave it to you guys to calculate this, put this on the calculator, and for that we'll leave it at that. Number 9, the cool science teacher performs a demonstration and finds that a piece of cork displaces that much water, so that's our volume, and weighs that much, that's our mass. Find the density. So the density is, so basically what happens is that you have a thing of water, essentially, right? Let's say this is at 100, and you put the cork in, a cork for, I guess, a wine bottle or something. You put it in, and then when it goes in, then the water gets displaced. The water level is now up here at 123.5 milliliters. And then you subtract those. You subtract 123 minus the original, and that's how you got that it displaced that much water. So just in case you're intrigued in how we got that. So that's the amount of water that was displaced. So anyways, the volume is that difference there. That's our volume. Okay, so it's going to be 5.7 grams divided by 23.5 mLs. So the density is in grams per milliliter here. All right. And I'll leave it to you guys to calculate that. Consider the table below of different types of solids and their densities. So while digging in the backyard, you find an old coin. If the mass is 26.7 grams and the volume is 3 centimeters, then determine what the coin is made of. All right, so let's calculate the density. The density is mass, 26.7 grams over, now the volume is 3 centimeters. So we put that in here, 3 centimeters. This should be 3 centimeters cubed, not 3 centimeters. So we get that it's 26.7 divided by 3, so it's 8.9 grams per centimeter cubed. So at most likely the coin is made out of copper, right? All right, so part B, a rectangular block of material is on your dad's desk that acts as a paperweight. The measurements are 3 by 4 by 6 and has a mass of that. So let's calculate the density. Now the volume is 3 times 4 times 6, right? So we got our mass is 184.32 grams divided by the volume, which is 3 by 4 by 6 centimeters cubed. So go ahead and divide those. Again, when you do this, put this in parentheses or something like that, or just calculate it on your own separately. We get about approximately 2.56 grams per centimeter cubed. So there's our density of that block, and that seems to be about the consistency of quartz. So it's made out of quartz. All right, so part C, in the play pit of the restaurant, you find the ring with the mass of 107 grams. You use water displacement to determine that the volume is 5. Determine what the ring is made of. So the density is mass over volume. We just divide that. So 21.4 grams per milliliter, which is platinum. All right, and then Eureka, you think you found a diamond. The mass is 5.28 grams. The volume is 2 cubic centimeters. Determine what you found. So the density is 5.28 grams divided by 2 cubic centimeters. And you get 2.64 grams per centimeter cubed, which unfortunately is not a diamond. The diamond is 3.52. What you actually have is a sample of, I guess it looks to be, oh, this is 21. Yeah, so okay, so it looks like you have, oh, okay, so this one was actually not quartz. This one was actually marble. So this is a marble. Apologize for that. What you actually have is quartz, right? So you have 2.64 is quartz. So this is a good way of finding out if you have, a certain material. You know the densities of materials. You can look them up in any scientific journal or any measurement, any book with measurements, or you can look it up online, and you can figure out what material you have, within reason. So sometimes you think something is a diamond. It might be fake diamonds, right? It might be cubic zirconium, or in this case, it happens to be quartz. So there you go. So lesson learned. Actually try to figure it out to see if it's actually what you think it is or not. All right, that's going to do it for the video, guys. Take care. I hope you learned something from this. And as usual, I'll see you in the next one.